Good evening. Today we are going to start new topic, that is applications of derivatives, an interesting topic. We are going to discuss few applications of derivatives. I have already explained this, but I will repeat that. I will explain geometrical interpretation of derivative. What does f dash of a represent geometrically? Let me explain. Consider the curve whose equation is y equal to fx. Now I consider secant pq. P is a f of a, and what is q? Q is a plus h, f of a plus h. See, if a point lies on the curve, coordinates satisfy the equation. So if x coordinate of the point P is a, what will be y coordinate? F of a. Simple. Now, how will you define tangent? Tangent is nothing but limiting position of secant PQ. Now, can you tell me what is slope of secant PQ? Slope secant PQ equal to, what is the formula for slope? Y2 minus Y1 upon X2 minus X1. So, f of a plus h minus f of a upon a plus h minus a, that is h. Now you will notice that as Q approaches P along the curve, as Q approaches P along the curve, limiting position of secant PQ is tangent at P. That is, when P and Q coincide, we get tangent at P. Now as Q approaches P, this difference h will tend to 0. So I can say, therefore, slope of tangent at P, is nothing but what? Limit h tends to 0, f of a plus h minus f of a divided by h. But note that right hand side is nothing but derivative of the function y equal to fx at x equal to a, which is denoted by f dash of a. Thus, what is f dash of a? F dash of a is nothing but slope of tangent to the curve y equal to fx at a point on the curve. See, this is quite logical. The point has to lie on the tangent, because if point doesn't lie on the tangent, then how can we find derivative at that particular point? Because in that case, the point will not belong to the domain of the function. Okay, I hope you have understood this. So what will be the equation of this tangent? Let me draw the diagram again. Suppose this is the curve and this is the tangent at the point P. Now, what are the coordinates of P? They are a, f of a. What is the equation of the curve? It is nothing but y equal to f of x. Now, to get the equation of line, two things are required: point on the line and slope of the line. Now, this tangent has slope f dash of a. We have just proved. So what will be the equation of line? We use point slope form, y minus y1 equal to m, that is slope, into x minus x1. Here x1 y1, that is point on the tangent, is a f of a. So equation is y minus f of a equal to slope f dash of a into x minus a. I hope you understood this. This is what? This is nothing but equation of tangent. Now, one more definition. Line perpendicular to tangent at point P is called as normal to the curve. As slope of tangent is f dash of a and product of slopes of two perpendicular lines is -1, what will be the slope of the normal? It will be -1 upon f dash of a. Now the point lies on normal also. So what will be its equation? It is y minus f of a equal to minus 1 upon f dash of a, okay, minus 1 upon f dash of a into what? X minus a. This is nothing but equation of normal. Okay, now give the title, write down, give the title, applications of derivatives. Applications of derivatives. In that, write down number 1, geometrical interpretation of f dash of a. Geometrical interpretation of f dash of a. In that, write down f dash of a, f dash of a, that is dy dx at x equal to a is the slope of the tangent, is the slope of the tangent to the curve, slope of tangent to the curve y equal to fx, y equal to fx at a point, at a point x equal to a on the curve, at a point x equal to a on the curve. Next line, dy dx is also called as, dy dx is also called as gradient of the curve, gradient, gradient of a curve. Okay, now draw this rough sketch, draw the rough sketch, show both tangent and normal. Okay, now we discuss second application of derivative, that is derivative as a rate measure. Suppose a function given by y equal to fx is differentiable at x equal to a. Now if x changes from a to a plus h, f of x will change from what? F of a to f of a plus h. So f of a plus h, see, f of a plus h minus f of a, right, is the change in fx corresponding to the change h in x. Now what is the average rate of change? It is f of a plus h minus fa upon h. Do you agree with me? Now if we take the limit of this as h tends to 0, okay, I will shift this to this side so that I can write limit h tends to 0. Clearly this is nothing but what? F dash of a. This is nothing but f dash of a. Now this has to exist because I have said that this is a differentiable function. Now it is called instantaneous rate of change of the function f at x equal to a. I repeat, f dash of a is called instantaneous rate of change of the function f at x equal to a. Hence we can say that the derivative, that is f dash of a, measures the rate of change of function f at x equal to a. Thus the derivative of a function is a rate measurer of the function. Okay, now we will discuss an important point, that is relative rates. Means what? Suppose we consider the function, y equal to fx. Don't write y equal to fx. Suppose this is a differentiable function. Assume that x and y are both functions of t, differentiable functions of t. So what I will do is I will differentiate both sides with respect to t. What is derivative of y with respect to t? dy dt. Now we have to find derivative of RHS also with respect to t by chain rule. What is ddt? It is ddx into dx dt by chain rule. So ddx of fx. So you will notice that dy dt is nothing but what is ddx of fx? F dash of x dx dt. So here we say that dy dt and dx dt are what? Related rates. Okay, I hope you have understood this. Now you will ask me, sir, when to use this. I'll give an example. We know that area of a circle is a function of radius. Suppose there is an increase in the radius of circle. As a result, the area of the circle will also increase. So here we say that differentiate both sides with respect to t. Now don't say that sir a is constant, so its derivative will be 0. See, a is now a function. As radius changes, area doesn't remain constant. It also changes. So I differentiate both sides with respect to t. So dA dt. Now pi is constant. What is derivative of r square? 2r. So I say 2 pi r dr dt. Is that clear? So this is how these two rates are related. Now give the title derivative as a rate measure. Write down derivative as a rate measure. In that write down the derivative f dash of a, the derivative f dash of a measures the rate of change of f, measures the rate of change of f at x equal to a, at x equal to a. Thus the derivative of a function, thus derivative of a function is a rate measurer of the function. Next line, give the title related rates. Related rates. Suppose y equal to fx is a differentiable function. Suppose y equal to fx is a differentiable function where x and y are differentiable functions of t, where x and y are differentiable functions of t, where x and y are differentiable functions of t. Full stop. Next line. On differentiating both sides, on differentiating both sides of y equal to fx, y equal to fx with respect to t, with respect to t, we get, write this directly, see on the screen, we get dy dt equal to f dash of x, dy dt equal to f dash of x dx dt. Write this much only, dy dt equal to f dash of x dx dt. Next line, this relation connects, this relation connects the rate of change of x and y, the rate of change of x and y with respect to t, with respect to t, and thus the rates dx dt, the rates dx dt and dy dt are related. The rates dx dt and dy dt are related. Okay. So what is the equation of the curve? Equation of the curve is nothing but y equal to, write that equation, x square plus 2 e raised to x plus 2. So curve is y equal to x square plus twice e raised to x plus 2. Okay. Now find out dy dx. So what is dy dx? Dy dx is nothing but, I hope you know, you remember all standard formulae. By the way, I have uploaded one video. I have sent you the link on group. So whenever you get time, please listen to it. It is on uh, derivative basics. So what is dy dx? It is 2x plus 2 e raised to x, because derivative of e raised to x is e raised to x. And what is derivative of constant? 0. Therefore, dy dx at which point? Because there are infinitely many points on the curve, tangent is drawn at which point? At 0, 4. So dy dx at 0, 4. I mean x coordinate is 0, y coordinate is 4. So this is 2 into 0 plus 2 into e raised to 0. So 0 plus, what is e raised to 0? 1. So this is nothing but 2. Now after that I will immediately write, this is nothing but slope of tangent. You better write tangent completely. Just don't write t. Write slope of tangent at which point? At 0, 4. Okay. So this is the slope. So what is the equation of tangent? I name this point as, say, P. Therefore, tangent at P is y minus y1 equal to m x minus x1. We could have written 2 equal to m, where m is the slope. Slope of a line is usually denoted by what? Small m. Therefore, y minus 4 equal to 2 into x minus 0. Generally, we write answer in this form, that is 2x minus y plus 4 equal to 0. Okay. So this is what? This is equation of tangent. Now after that, what will be the slope of normal? Negative reciprocal of 2y, because product of slopes of two perpendicular lines is minus 1. You need not write this in exam. You can directly write. Therefore, slope of normal, write this completely, just don't write n. Slope of normal is minus 1 upon 2. So what is equation of normal? Therefore, equation of normal is y minus 4, point is the same, minus half x minus 0. Rearrange the terms and tell me the answer. Tell me the answer. I think it will be x plus 2y minus 8 equal to 0. X plus 2y minus 8 equal to 0. So this is what? This is equation of normal to the curve at a point 0, 4 on the curve. So what is the equation? It is x square minus root 3xy plus 2y square equal to 5. Now tell me what is derivative. Differentiate. So 2x, this is an implicit function. So 2x minus root 3 into what? What is derivative of xy? X dy dx plus y into derivative of x, which is 1, plus 2. What is derivative of y square? It is 2y dy dx. What is derivative of 5? 0. Now you have to solve this equation for dy dx. Open all the brackets and tell me what is dy dx. I write this directly. So if I take dy dx common, see what I get in bracket. I think I will get 4y, okay, 4y minus root 3x. Check this. See, x is not under radical sign. You have to be careful. Equal to what? Equal to, it will be root 3y. Just check. Root 3y minus 2x. See, just open the brackets, rearrange the terms. Not at all difficult. You have to be careful. So dy dx is what? It is root 3y minus 2x upon 4y minus root 3x. Okay. I hope that this is correct. Now tangent is drawn at which point? Root 3 comma 2. Therefore, slope of tangent at which point? At root 3 comma 2. At root 3 comma 2 is, I will write m equal to, I have just changed the presentation part. So what is m? Replace every x by x coordinate, that is root 3, and y by y coordinate. So this is root 3 into 2 minus 2 into root 3. Okay. Upon 4 into 2 minus root 3 into root 3. Okay. Denominator is not coming as 0. So it is 0. I'm sorry, denominator. Yes, denominator is not 0. 0 upon non-zero, which is nothing but 0. So slope of, sorry, slope of tangent is 0. Therefore, what is equation? Equation of tangent? Equation of tangent is y minus y1, that is y minus 2, equal to slope x minus x1. So x minus root 3. That is what? That is y minus 2 equal to 0. Write down. Y minus 2 equal to 0. Now next part is important. See, slope of x-axis is 0. So tangent is parallel to x-axis. So normal will be what? Perpendicular to x-axis. Right? I will say normal is parallel to y-axis. Parallel to y-axis. Now what will be its equation then? Therefore, its equation is, if a line is parallel to y-axis, then its equation is x equal to constant. I'll explain why. Okay. But as which point? Root 3 comma 2 lies on tangent, sorry, lies on normal. We have to say it lies on tangent also, but here we have to say lies on normal. So coordinates will satisfy the equation. Therefore, root 3 equal to k. Therefore, equation of normal is x equal to root 3. Write down. You write down, then I'll explain why I have written that normal is parallel to y-axis. Now the next curve is 2xy plus pi sine y equal to 2 pi. You have to say differentiating both sides with respect to x. Therefore, you get what? 2 into, what is derivative of xy? It is x dy dx plus y into derivative of x, which is 1, plus pi. What is derivative of sine y? Not only cos y multiplied by dy dx. And what is derivative of right hand side? It is nothing but 0. Now rearrange the terms and tell me what is dy dx. So this is 2x dy dx, okay, plus 2y plus pi cos y dy dx is nothing but 0. So take dy dx common to get 2x plus pi cos y. So we are revising derivatives equal to what? Minus 2y. So gradient of the curve dy dx is minus 2y upon 2x plus pi cos y. Now tangent is drawn at which point? This is just the gradient of the curve. Now tangent is drawn at 1 pi by 2. As tangent is drawn at 1 comma pi by 2. Okay. What will be the slope? Find out. Replace every x by 1 and y by what? Pi by 2. Therefore, slope of tangent is nothing but minus 2 into pi by 2 upon 2 into 1 plus pi cos pi by 2. What is cos pi by 2? Cos pi by 2 equal to 0. So this is minus pi upon 2 plus 0. So what is the slope of tangent? It is minus pi by 2. Now slope of the line is known. A point on the line is known. So we are in a position to write its equation. Better that represent this by m. Therefore, equation of tangent y minus y1. So y minus pi by 2 equal to slope minus pi by 2 into x minus x1, that is x minus 1. Now open the bracket, simplify and tell me the answer. You should be able to solve this on your own. Don't wait for me. I will write the answer. You will have to check it. Multiply by 2, bring minus pi x to LHS. So it is pi x plus 2y minus 2 pi equal to 0. This is what? This is nothing but equation of tangent. Slope of normal, it is nothing but minus 1 upon m. That is minus 1 upon what? Minus pi by 2, which is nothing but 2 upon pi. Now normal also passes through the same point. So write its equation. Y minus pi by 2 equal to slope, which is 2 upon pi into x minus 1. Now multiply throughout by 2 pi and tell me what is the answer. No. Archit, keep log 4 as it is. Okay, so we start some number 4. Now when t equal to 4, when t equal to 4, tell me what is x. X is root 4, that is 2. And what is y? Y is nothing but 4 minus 1 upon root 4. That is 4 minus half, which is nothing but 7 upon 2. Okay. Therefore, tangent is drawn. Tangent is drawn at which point? At 2 comma 7 by 2. Is that clear? Okay. Now let us find dy dx as x equal to what? Root t. What is dx dt? See, this is basically derivative of parametric function. Derivative of root t is 1 upon 2 root t. Simple. Now write y. What is y? Y is nothing but t minus 1 upon root t. Okay. T minus 1 upon root t. So what is dy dt? Dy dt is nothing but 1 minus, what is derivative of 1 upon root t? I will write minus ddt of 1 upon root t is t raised to minus half. Okay. And therefore, dy dt is nothing but 1 as it is. What is derivative of t raised to minus half? Derivative of t raised to n is n. T raised to n minus 1. So minus 3 by 2. I hope you are getting this. So 1 plus half t raised to minus 3 by 2 is what? Is nothing but dy dt. Now this is case of parametric. So what is dy dx? Dy dx is nothing but dy dt upon dx dt. Upon dx dt. So this is nothing but substitute 1 plus half. Now I will write t raised to minus 3 by 2 as okay, जो है वो है, लिखना ही पड़ेगा. T raised to minus 3 by 2, okay, upon what? What is dx dt? Dx dt is 1 upon 2 root t. Okay. Now let us simplify this using laws of indices. Now t raised to minus 3 by 2. See, this is basically a sum of laws of indices, right? Okay, no problem. So 1 upon 2. Now t raised to 3 by 2. I better write this as t root t. Hope you are getting my point. T raised to 3 by 2 means t root t only. Upon what? 1 upon 2 root t. This is better. Now we are simplifying dy dx only. So this is nothing but multiply numerator and denominator by 2t root t. So this is 2 t root t. Okay. 2 t root t plus 1 upon, I have multiplied numerator and denominator by 2t root t rather. So this will be what? 2 root t cancel. So it will be just t. So what is dy dx? Finally, dy dx is finally 2 root t, okay, plus 1 upon t. But t is what? t is 4. So this is 2 root 4 plus 1 upon 4. So 2 into 2 plus 1 upon 4. That is what? It is nothing but 17 by 4, is it? So 17 by 4 is nothing but the answer for slope, not the final answer. So this is slope of tangent. So what is the equation? Find out. We know that the point 27 by 2 lies on the tangent. So find out its equation. As 27 by 2 lies on curve and on tangent also. What is the equation of tangent? Y minus 7 by 2 equal to m. What is slope? It is 17 by 4 into x minus 2. Yes, ये बराबर है. Now you will have to simplify this. I will not explain simplification part. But what I would have done, I would have multiplied throughout by 4. So this is 17x minus 4y minus 20 equal to 0. So this is tangent. Now find out equation of normal. Now what will be the slope of normal? It is minus 1 upon slope of tangent, that is minus 4 by 17. Normal also passes through the same point. So what will be its equation? Y minus y1 equal to m x minus x1. That is y minus 7 by 2 equal to minus 4 upon 17 x minus 2. Rearrange the terms to get 8x plus 34y minus 135 equal to 0 as equation of normal. Write down.